All right, so tonight we're working on chapter 9, and there are two major problems. Actually, let me switch to something a little different. There are two main types of problems here. There is what we call a confidence interval problem and a sample size problem. And so a confidence interval problem is where we're looking to estimate the percentage of a population that has a certain characteristic or the mean of a population between this number and that number. A sample size problem is when we're trying to figure out how big of a sample do we need before we can make that estimate. Now, for each of these problems, it could either involve a proportion or a mean. And we're going to talk about how to make that first decision, which is actually a little easier. And the second decision, which if you have a set of rules, it's not so bad either. I do want to point out that in the Canvas site, there is a page that talks about these two sections. So let me get to that real quickly, show you where that is. If you go to week 10, or do I call it week 9? Week 10, there is a set of notes that compares the two sections and a short video where I compare the two sections. I think that that is the best way to wrap this up. And this is a good place to start your notes for the final. The final exam basically begins with chapter 9. So it's like we're starting over. And this is a good way for figuring out what type of problems you're dealing with. Oh, I forgot. There is a reading assignment that goes with these chapters. I may actually open it up next week instead, because I haven't given you enough time to do that. Anyway, we'll take care of that in a little bit. Where's that? Oh, it might just be chapters 9 and 10. That might make more sense. Anyway, definitely pay attention to these. So even though there's no points involved here, it's definitely worth your while to print out my notes and then watch that video. If you can't identify what type of problem it is, it doesn't matter how you do it. If you pick the wrong problem, it's a 0 on that problem. So you definitely want to make sure that you can spot these. Now, for confidence interval problems, they're going to come right out and say, construct a confidence interval. And for sample size problems, it won't say make a confidence interval. It will always ask, how big of a sample do we need? So if we go back to tonight's problems, and let me blow this up again. I want to take a look at problems 1, 3, and 4. Problem 1. I keep clicking on my screen thinking that that's going to work, but I need to click on the iPad. Problem 1 says, construct a confidence interval. Problem 3 says, construct a confidence interval. Problem 4, construct a confidence interval. So the confidence interval problems, they just come right out and say, we want you to estimate this proportion or this mean with a confidence interval. But if you look at problem 2, it doesn't say to make a confidence interval. Yes, it says that they want to be 95% confident, but what it really asks for is how large of a sample do we need? And if you look at problem 5, the same thing happens. How large of a sample is needed? So it's asking for something different. So that first decision point, confidence intervals will say, construct a blank percent confidence interval. And the sample size problems will say something about how large of a sample is needed. So that's the first difference. But there is another difference that I think is pretty important too. Let me change colors for that. For a confidence interval, you will be given a sample. And for sample size problems, you will not have sample information. So the confidence interval gets built from a sample. The sample size problem comes before you have the sample. How big of a sample do we need to take in order to make that confidence interval? So those are a couple of things that you can be looking for. If I go back to tonight's worksheet again, in problem 1, we have a sample of 435 people and 49 were left-handed. That problem has a sample in it. But in problem 2, we don't have a sample. We don't know how many people were interviewed, and we don't know how many of them washed their hands after using a public restroom. So we don't have the sample in that one. That's another good sign that it's a sample size problem instead of a confidence. All right. The second part is once you know it's a confidence interval or a sample size problem, you also need to be able to figure out whether it is for a proportion or a mean. And the same kind of thing happens for a proportion. You will have a sample that is this many out of that many. And the variable needs to be categorical. So what that means is if you ask your question to gather the data, you want to think about what kind of answers you're going to get back. And if you're expecting categories, not numbers, if you're expecting yes or no answers, that's categorical. You should be working with a proportion. So let's take a look at the first problem and see why this is a confidence interval for a proportion. The sample in this problem is 49 out of 435. And think about the question that you would ask. The question would be, are you left-handed? And the answers are going to be either yes or no. Or you might ask, what's your dominant hand? And people might say right, left, or other, or both. And we're counting up how many said left. Those are categories. And that also means proportion. So X out of N with categorical variable, that is a confidence interval for a proportion. Now, to do this in StatCrunch, we don't have to enter any data. We're just going to use proportion stats, one sample with summary. Stat proportion, one sample summary. And this is actually pretty friendly to do. You enter the number of successes. Let me get that picture out of the way. So the number of successes is 49 out of the number of observations, 435. That's the sample size. So 49 out of 435. That's the order that we enter them in. Then you have to click where it says confidence interval. And the last thing we have to enter is the level of confidence, which we were told was 95% for this problem, 0.95. And that's what it's going to be defaulted to. Just be careful because we also use things like 90%, 99%, and you want to make sure that if it's different than 0.95, you enter it. Never change the standard method, and that's all we need to click. So your number for X, your number for N, and the button for confidence interval and the level. Compute. And the two numbers that we want are listed under lower limit and upper limit. Those are the bounds for the confidence interval. So typically we go to 4 places in my lab. Just be careful that sometimes it'll say round them to 3 places, but to 4 places, we've got 0.0829 as the lower limit and 0.1424 for the upper limit. The number next to the 3 was a 5, so that gets rounded up. We're 95% confident that the proportion of all people, not just the people in the sample, but all people that are left-handed is somewhere between 0.0829 and 0.1424, or between, say, 8.3% and 14.2%. Based on this sample of just 435 people, we're able to make that inference out to all people. We can estimate that percentage. It's between 0.0829 and 0.1424. You will typically be asked for a sentence, so it would be something like, let me write it at the top. We are 95% confident that the proportion of all people who are left-handed is between 0.0829 and 0.1424. Now, so when you take your Chapter 9 activity, when you do the final exam, I am going to ask you to include that in a sentence. And the sentence has these parts. First, how confident are we? What are we measuring? And the lower and upper limits. One other thing that shows up in the video lecture that I'm not asking for in tonight's work is the margin of error. And the margin of error you can find by taking the upper limit and subtracting the sample proportion. Sample proportion is that p hat that we started to see in Chapter 8. So here you would take 0.1424 and subtract 0.1126. That's the margin of error. And if you subtracted that out, you get 0.0294 or about 0.03. That means that our sample, we're 95% sure, is within about 3% of the real proportion. It could be 3% higher than what we saw in our sample, or 3% lower than what we saw in our sample. Anyway, it's not asked for here, but you should be aware of how to find that. And again, it's always the upper limit minus the result from the sample. All right, any questions on that one before we take a look at the second problem? Again, you can either unmute yourself and ask them out loud, or you can type it into the chat.
Will finding like what you just did, will that be on the final?
Yeah, so starting with this section, that's where the final begins, and everything that's here tonight is on the final for sure.
Okay, so it's chapters 9
through 13. Yeah,
final.
that's right. Yeah, we start over from scratch, Carissa. So some of those things that we learned in the first 8 chapters will be part of problems as we go, like figuring out if a set of data is normally distributed with a QQ plot, or using the normal calculator. But for the most part, it's all brand new stuff, which is good, right? If you kind of struggled a little bit, right, it's a chance to kind of restart from scratch, right? We're all even again. But if you did well, you still got to continue to do well because it's like a brand new class almost.
Okay, thank you.
Yeah, you bet. Now in problem 2, where we're looking for a sample size, and the next thing we got to figure out, is it for a proportion or a mean? And this is for a proportion. Let me write that down first, and then I'll show you why that's true. The researcher wants to estimate the proportion of all people who wash their hands after using a public restroom. How large of a sample? There's my sample size clue. Does the researcher need to be 95% confident in their estimate that their estimate is within 4% of the true proportion? So first, I see the word proportion floating around. So that's a good sign that it's a proportion problem. Within 4%, when we're given a percentage that we want to be within, that's another good sign that it's a proportion. And then finally, this is a categorical variable, because what we would be recording for each individual is whether they wash their hands or not. Those are categories, not numbers. So everything here says proportion. Now, what we need to do this problem is we need to know the confidence level. We need to know what's called the target proportion. Let me write that out all the way. We need to know the margin of error. We need to know the width, which is 2 times the margin of error. And StatCrunch will then calculate the sample size for us. So where do we find these pieces? The confidence level has to be given to you. And here, we want to be 95% confident. That confidence level is 0.95. The width is double the margin of error, and the margin of error is how close we want to get to the actual answer. So when it says within 4%, that's the margin of error. Right? It can be 4% higher or 4% lower. So in this case, it's going to be 2 times that, or 0.08. And again, the idea is that it could be 4% higher or 4% lower. From side to side, that's 0.04 and 0.04 or 0.08. The target proportion, that's an estimate if you have it. Now, typically, if you're trying to estimate the proportion, you won't have an estimate to work off of, but sometimes you may have an estimate. And if you do have an estimate, it allows you to sample a smaller size sample to generate those results. And a smaller sample means you spend less time and money, which is always good too. But typically, we use 0.5 if it's unknown. So if the problem said, past research has shown that about 15% of all people don't wash their hands, then you could use 0.15 for the target proportion. But in this problem, it doesn't say. So if you don't know what that is, we use 0.5 every time. In the MyLab problems, each of these problems is typically 2 parts. One part, they will give you the estimate, and then one part, they won't give you an estimate. In that part, you'll use 0.5. In StatCrunch, the way that we get there, this is also under stat, proportions, one sample, just like the last one. But at the very end, we choose the option that says width, sample size. So those are the steps inside StatCrunch to get here. And the 3 numbers we're going to enter, 0.95, 0.08 for the width, and 0.5 for the target proportion. Let's take a look at where that is. Get rid of the first problem. Stat, proportion, one sample, and then this option that says width, sample size. And we get a box that we need to fill in. The confidence level is 0.95, that's already there. The target is 0.5, that's already there. We just have to enter the width. And by the way, the biggest mistake that students make is converting 4% to a decimal. 4% is 0.04, not 0.4. 0.4 would be 40%. Remember, when you have a percent, you want to move the decimal point 2 places to the left. So if you had 4%, we get rid of the percent and we move it 2 places to the left, that's 0.04. That's enter 0.08. That's the other common mistake, is not doubling that margin of error. So we see the 0.04 in the problem and we just write it down, and you end up with a sample size that's about 4 times off of what it should be. Compute, and that will give you a whole number. That whole number is the answer, 601. So what that means in this problem is if you sample 601 people, you will be 95% sure that your sample is within 4% of the percentage for all people, not just the ones that you observed, but for all people. Just a couple of things to point out there. Again, if the target proportion is unknown, we use 0.5 for that. The error, make sure you move the percentage 2 places to the left, and then you double it to get the width. Those are the two places where things can go astray the easiest. All right, before we move on to the other problems, which all deal with the mean, I did want to show you something in StatCrunch in this activity, the worksheet for the Chapter 9 activity. Let me just open it up in its own window. The first 2 problems are confidence intervals for a proportion. So that first page, and notice again, construct a confidence interval for a proportion. The variable is categorical. We would ask people, did you vote in the last election? Their answers are going to be yes or no. And then the sample is 183 out of 300. So everything there says this is a confidence interval for a proportion. The second problem, same idea. For problem 3, how many people must she survey? So this one's asking how big of a sample do we need? She's trying to estimate the percentage that use self-checkout. She wants to be off by no more than 6%. There's a percentage there. That's also telling us it's a proportion problem. And problem 4 is the same idea. The remaining problems deal with the mean. And so let's switch pages one more time. For a mean, you have, let me write it down here. You might have a sample summary, which is the mean, the standard deviation, and the size. So, oops, sorry. Should have been looking at the big screen. So when you work with a mean, you might have a sample where it's been summarized. They'll tell you what the mean is, what the standard deviation is, and what the size of the sample is. Or you might have a sample that gives you the data. You'll have a value, a value, a value, and so on. That's working with data. Also, which you can tell from the numbers down here, this is a numerical variable, not a categorical variable. So if you think about what question you would ask, and what answer you would get, you're expecting numbers back this time. So let's take a look at problem 3. We already saw where it said construct a 99% confidence interval. A recent poll asked 1,006 adult Americans how many books they read within the last year. We're given a sample mean and a sample standard deviation. So we've got a summary of the sample. Right? The sample mean was 13.6 books. The sample standard deviation was 16.6 books. And the sample size were the 1,006 adult Americans we asked. Now think about the question you would ask these people. You would ask them, how many books did you read within the last year? And the answer that we're expecting back is going to be a number. So this is a numerical variable. Everything here points to a confidence interval for a mean, not a proportion. One other thing is in StatCrunch, if you tried to do this as a proportion, you'd have a hard time filling in those boxes. You'd have all this extra information you wouldn't know what to do with. This is going to be found under stat, t-stats, one sample, and you have two options there. It could either be summary or data. This one's going to be summary because we already know the mean and the standard deviation. In problem 4, where we just have the numbers, but not the mean and the standard deviation, that one's going to be with data instead. So into StatCrunch, we're going to need these 3 numbers and the confidence level. When we work with means, typically we round these to 1 places, but again, in my lab, just be careful, pay attention to where they tell you to round. So as I mentioned, going down these steps again, stat, t-stats, 1 sample with summary. Now, if I click on with data by mistake, it asks me for a column that I don't even have. So I know I'm in the wrong place there. Stat, summary, stat, t-stats, 1 sample with summary. The sample mean was the 13.6. Standard deviation was 16.6. The size was 1,006. We click on the confidence interval. And again, be careful that you check the level. This was 99%, so 0.99. If you pick 0.95, your answer is going to be a smaller interval than we really need at 99%. Compute. And everything's in the same place, lower limit and upper limit. And if we round this to 1 place, this first one's going to be 12.2. And the next one's going to be 15.0. So we're 99% confident that the mean number of books read by all adult Americans last year was between 12.2 and 15.0 books. So from these 1,000 adults, we're able to talk about the hundreds of millions of adults in the United States. And we know that it's somewhere between those 2 numbers. Now for the sentence, it really is going back. If you look at just the last line of the problem, construct a 99% confidence interval for the mean number of books read by all adult Americans last year. Let me clean this up just a little bit. Hide some of this. We want to start with, we are 99% confident that the mean number of books read by all adult Americans last year is between those two numbers. That's how you write the sentence. How confident are you? What are you estimating? And where is it between? So I'm going to write that out at the bottom, but I will erase it in just a moment. We are 99% confident that, and then I get to what I'm estimating, the mean number of books read by all adult Americans is between, and then we had 12.2 and 15.0. And let me change this in case, I know when it records, sometimes it hides that behind the video. So let's get it over there. And again, that just comes out of the statement of the problem. We're 99% confident that, and then we list what we're trying to estimate. And then finally, we end with what it's between. I'll leave that on the sheet for just a little bit longer while we do problem 4, but I'll erase it before we try problem 5. Any questions on that one before we go on?
Sorry, I have a question. I'm so sorry. For the, do we have to write out the question like for each problem?
You do need to write a sentence to summarize your results. You don't need to repeat, like if you're doing this on your own paper, for the chapter activity, you don't need to rewrite the problem, but you will need to answer in a sentence.
Okay, thank you.
Yeah, you bet. So this is the right answer. Even though these were the right numbers, you do need the sentence to describe it. All right. Number 4 is basically the same idea where we are looking for a confidence interval. We've got a variable that's numerical, right? We can see the numbers on the page, but we would ask a parent, how many weeks did it take for your baby to crawl? And we would get an answer, a numerical answer, 38 weeks, 56 weeks, whatever it may be, but we're expecting numbers back. And numbers tell us that we're dealing with a mean. Also, it does say for the mean age, so that helps. But what's different about this problem is that I don't know the sample mean. I don't know the standard deviation, but that doesn't matter because I can type these numbers into a column in StatCrunch, and StatCrunch can do the calculations from there. So the major difference here is that this one's going to be stat t-stats, one sample, but with data, because we actually have the data. So confidence intervals for a mean can be either like problem 3, where you already know the sample mean, or problem 4, where you just have the numbers from the sample. So the first thing that I've got to do is I've got to type those numbers into StatCrunch. And I said this for the midterm, but I'm going to say it again. When we're thinking about the final exam, we need to have somebody make sure that we've typed the numbers correctly, whether that's ourselves, if we're able to be disciplined enough and make sure we type them all right, or have one other person that look at the numbers to make sure you enter them correctly. We have 52, 30, 44, 35, 39, 26, 47, 37, 56, 26, 39, and 28. And then, you want to go through and make sure they match up. So I look at my last number on the page was 28. There's a 28. Then it's 39. Then it's 39. I can go one at a time, or on the final exam, have somebody read what you typed and you verify as they read them. Because if you've got the wrong numbers in there, you cannot get the right answer out. So I know it's like a simple thing, but you really want to be careful when you do that. Once they're all in, T-stats, one sample with data. And if you picked with summary by mistake, it would ask you for the mean and you wouldn't have a mean to work with. So you would know you're in the wrong place. Pick the column, pick the confidence interval, and enter the level. This time it was 0.95. So this one's ready to go. Compute. And we get our lower limit and upper limit at the bottom corner again. So this time the lower limit is 31.9 weeks and the upper limit is 44.6 weeks. We didn't talk about margin of error on the last problem, but we can do it here. The sample mean is here. You just take the upper limit minus that sample mean. So 44.6 minus 38.3 is 6.3. So we're within 6.3 weeks either way. Let's talk about what the sentence would look like. Let me make this a little bigger again. Oops. Sorry, hang on. I think I broke the iPad. There it was. Hit the focus button by mistake. Sorry about that. So let's take a look at the wording for the sentence. It would start with, we are 95% confident that the mean age at which a baby first crawls is between those two numbers. We are so many percent confident that, then we list what we're trying to estimate, which will be stated in the problem. And then we say is between the lower limit and the upper limit. Get rid of this. So we can take a look at the last problem. Any questions on 3 or 4? If I bring back the chapter 9 activity, if we go to the next page, confidence intervals for a mean, this one, we're given the mean and standard deviation for the sample. This is a summary problem. But if you look at problem 6, you're given the diameters of 10 trees. You're given the numbers. This is with data rather than with summary. So you've got one of each of those. The last part for sample size, switch colors, for proportion, the error is given as a percentage. And again, it is categorical. For a mean, though, haven't been used yet. Try that one. For a mean, the error that you're given, how close we want to be, will not be a percentage. You will be given a standard deviation. That's different. And the variable will be numerical. So when it comes to the information, I actually think that the standard deviation is probably the most important part here. Because only the mean problems will have a standard deviation, the proportion ones will not. Sorry. So if we look at problem 5, again, it's asking for how large of a sample we need. It doesn't say make a 90% confidence interval. It says we want to be 90% confident, but it doesn't say to make a confidence interval. And we don't have a sample. We don't have a mean to work with. Everything here says it's a sample size problem. For the sample size problem, what we need is the confidence level. We need to know what the standard deviation is, and that's really just an estimate of the standard deviation. And again, we need the width, which is 2 times the error, how close we want to be. So I think that it's a good idea to write these 3 things down first. And then when we read through the problem, you know, there's a book called How to Solve It that was written in the 1950s. And it really was about solving word problems. And his first piece of advice for solving word problems is to read the problem. And then the second piece of advice is to read the problem again. The first time, we're just trying to get an idea about what the problem is about and what type it is. So I read through it quickly, see how large of a sample. I see a lot of things that tell me it's for a mean. So I know it's a sample size mean problem. Now, the second time I read it, I want to start picking off the information. So as I read it from the beginning, how large of a sample is needed to estimate the mean number of hours slept per night by college students if we desire to be 90% confident? The confidence level is 0.90. That our sample mean is within 0.5 hours of the mean. So the error is 0.5. 2 times that is 1.0. The population standard deviation for all people is estimated to be 3.2 hours. Oops, I did it again. There we go. 3.2. And so when we enter those into StatCrunch, it's going to give us the sample size at that point. The steps, this one's a little different. So this one is unique in that it's under stat Z stats. So typically when we work with proportions, it's under proportions. And when we work with means, it's under T stats, like it was in problems 3 and 4. But when we need a sample size, we need to use Z instead of T. Then underneath that, one sample, and again, it's width, sample size. Now you want to be careful because if you go to T-stats instead, it will also have these menu options, and you're going to get a sample size that actually is a little bigger than it needs to be. So be sure that you use Z-stats when it's sample size for a mean. Stat Z, one sample with sample size. Because I've already written down my information, it makes it a lot easier to just plug this in. 0.90 for the confidence level. Standard deviation is 3.2, and the width is 1.0. Oops. Compute. And there is our sample size. 111 is how big of a sample we need to conduct to be 90% sure that we're within a half hour of the mean for all college students. Now, I mentioned that T has the same thing, T1 width. And if I enter all the same information, 0.90, oops, 3.2 and 1.0, get slightly bigger answer than we need. So my lab will only mark the 111 right, not the 113. And I would take points off for the 113 because you used the wrong procedure. So be sure that you use Z stats here. And getting back to something that Carissa and I were talking about here, when we're talking about answers for sample size problems, just the sample size is all I need. So 111 is all I need to see from you. I don't need a sentence for that, just for the confidence intervals. If you look at the chapter 9 activity, problems 7 and 8 are sample size for mean problems. Researcher wants to estimate the mean number of hours members of a local club work out per week. How large of a sample should she take? That tells me sample size. I see that I'm given a standard deviation. That tells me it's a mean. The word mean tells me it's a mean. And because it involves the number of hours, if we asked a person at that health club, how many hours did you work out this week? We are going to get a number. It's a numerical variable. So all those things say it's for the mean. How large of a sample tells us it's a sample size problem. Everything else tells us that it's for the mean. And if you look at number 8, same kind of thing. How large of a sample must you take? The margin of error is not a percentage. I didn't mention that in the last one, but within 0.4 years, there's no percentage there. We have a standard deviation. And she wants to determine the mean time, and it's the mean time it takes students at her school to earn a bachelor's degree. So we would ask students who graduated, how many years did it take you? Their answer is going to be a number, numerical, goes with mean. All right, any questions on any of these 5 problems before we wrap it up for the night? I'm going to pull up the page that has the notes comparing 9.2.
Are we able to take a screenshot of the Zoom so I could have what's on your iPad that's visible?
What's there right now?
Yeah.
Yeah, so I'm going to actually upload this document that I've written all over. I will upload that into Canvas when I upload the link for the recording as well. And I'll show you where that's going to be. So I've got the Canvas class open in the left-hand window, and in the top module, sorry, it's moving on me. In the top module that says Math 21 Resources, there is a page called Zoom Recordings. And it'll go at the top of this list. There'll be a link to the recording. There'll be a passcode, like a password that you need to see the recording. And then there'll be a piece that says Mr. Woodbury's notes. That's where I will post this exact piece right here.
Okay, thank you.
Yeah. Let's see. Oh, I'm sorry. Give me just a minute on that one, Robert. I did want to show you, this is the page which kind of goes along with that flow chart that we developed earlier. What to look for confidence intervals, conditions that you have to verify first. And then there's also a page about calculating those. And then there's a page for sample size problems. And there's a video where I walk through all of those. So I think that's valuable. All right, Robert, let me pull that problem back up. Problem 7 says that she wants to be off by no more than 2 hours. So the width is going to be 4. That's right. 2 times that 2 is going to be 4. If we look at problem 8, she wants the president wants to be within 0.4 years. So 2 times 0.4, that'll be 0.8 for the width. So there's really 4 main types of problems, even though the ones for the means have a couple of different flavors, but there are 4 major problems here, and you should expect to see all 4 of those again on the final. Once we get to chapter 10 next week, we'll learn a new procedure called a hypothesis test, and the rest of the semester are just different flavors of that hypothesis test. We cover 10 or 11 different ones. And so it's going to be a matter of we're only going to cover 2 the first week, and it's going to be getting those 2 under control. And then the steps are the same the rest of the way. There's just little details that change from this section to that section to that section. And so once we get the main steps under control, it's actually a pretty friendly finish. So if you're ever going to have 2 really good weeks in this class, make them these 2, because it'll make the rest of the semester a lot easier for you. These are 2 really important weeks. All right, I'm going to stop the recording and